Hello arithmetic students! This video is all about unit conversions. Let's look at those words real quick. Conversion, you may have heard in other contexts like religious context or chemistry, right? Converting one chemical into a different one. But it means essentially to change. And when we talk about units, that is how you measure something. Measurement. Like inches is a unit, meters is a unit, kilograms is a unit. So what we're doing in this lesson is going to be measurement changes. You don't always want to measure the same thing. Let's look first at fractions without any words. We'll add some words in a little while. This is a fraction multiplication problem. And we talked before about how you can simplify the problem. 2/8, just looking at that fraction alone. If you break it down using prime factorization, chunking it out, then you can look at 2 over 2 times 2 times 2. That's really 8. Now, if you look just at the 2 where there's 1 on the top and 1 on the bottom, 1 in the numerator, 1 in the denominator, 2 divided by 2 or 2 halves, any way you look at that, is 1. And you may have heard people say before that things cancel out, but really what's happening is they're becoming 1. And so we have left over a 1 divided by 2 times 2, or 1/4. Now if we look at the 5 over 15, 5 doesn't break down any further, but the 15 we can break down to 5 times 3. And again, we're getting a 1 here, or crossing that out. So this one becomes just 1 over the 3 that was left. And we can multiply across. 1 times 1 is 1. 4 times 3 is 12. Now this crossing out or canceling things doesn't have to be within the same fraction if you're just multiplying everything anyway. So again, this 4 in the second problem here, we can break down to 2 times 2. 11 doesn't break down. Same with the 3. And we already know from the first problem that 8 breaks down into 3 2s. Now if I just multiplied everything here, but without getting the answer yet, on the top I'd had 2 times 2, and then times 3, and on the bottom I'd have 11 times those 3 2s. So here I still have just one fraction. I'm going to simplify it. I have a 2 on the top, 2 on the bottom, a 2 on the top, 2 on the bottom. So I'm left with 3 over 11 times 2, or 22, which is easier than multiplying them at the beginning and then simplifying the fraction once I have an answer. I can just simplify along the way. Let's look at another one like that. 10 over 63 times 21 over 55. And let's break it down. I'm just going to write it small right here. 2 times, whoops, that's a big multiplication sign. 2 times 5 is 10. 21 is 3 times 7. 55 is 5 times 11. Oops, get ahead of myself. 63, that's 9 and 7, and then the 9 can break down into 2 3s. So 3 times 3 times 7. Let's give myself a little more room with that 7. All right. Can you see anything crossing out? Look it over. We've got 1 5 on top and 1 5 on bottom. A 7 on top and bottom. Another 3 on top and bottom. And I think that's everything. We got a 2 left in the numerator. And on the denominator, we got a 3 and 11, so 33. Like the opposite of the last problem we did. Okay, I'm going to let you do the fun one. So I want you to pause the video and try this last one. It's going to be so fun. Ready, go. Welcome back. Did you have fun crossing things out? Oh yeah. We got a 3 on top, 3 on bottom. 7 on top, 7 on bottom. You gotta be careful not to cross out things you didn't mean to cross out. 5 and a 5, we're left with 2 and 13. Before, we had to multiply 3 times 7 times 2 times 5, get an answer, then simplify it. This is going to be an easier problem for sure. So this is summarized. The idea here is that if you have the same thing on top and bottom of a fraction, and everything else is just multiplying, you can cross them out. But that's not just true for fractions and numbers. It's true for words. This is gonna feel a little weird because you're like, I'm just gonna cross out a whole word. Am I editing an essay? Weird. Yep. You're gonna cross out a whole word. So we have here an example: 5,700 cents. All right, lots of money there, and we're gonna multiply it by $1 over 100 cents. Now this might look a little weird, like I said, with the words. But I want to just point out, $1 over 100 cents, that's really one whole. Those are the same exact things. It's like saying 3 over 3, or 32 over 32. If you multiply by 1, you're not changing the actual value of the numbers that you're dealing with. You're just changing how they look. So if we were to multiply these, let's go ahead, since this is a whole number, let's put it over 1. So I'm going to multiply the numbers, but what is crossing out? The word cents. Because we're no longer going to be dealing with cents. We're going to have our answer is just going to be in dollars. We're dividing the cents out. So we're going to have 5,700 times $1 over 100 divided by 100. That simplifies, of course, to be $57. There are $57 in 5,700 cents. If you have that many cents, you have $57. And we can use this fraction to convert from cents to dollars. That's what we're doing. We're doing unit conversion. Let me show you another example. Here we have, there are 12 inches per foot. Sometimes you'll see a 1 in the denominator, but not always. 12 inches for 1 foot, and 3 feet for 1 yard. But if it helps, you can always put the 1s in if you prefer that. 1. So we have 12. What's crossing out? Wait. What's crossing out? We have feet and feet here. So those are crossing out. Our answer then is going to be left with in the numerator inches and the denominator yard. So we're going to figure out how many inches are in 1 yard. So we'll go ahead and multiply the numbers that are left. 12 inches times 3 is 36 inches. 1 foot times 1 yard. Well, the feet are gone. The foot is gone. 1 times 1 is 1 yard. Or you can say 36 inches per 1 yard. 36 inches in 1 yard. And I did just say a word that might be new to you, and maybe not thought about it this way. The word per, as in miles per hour or inches per yard. And what it means is it means division or a fraction. So if you see the word per, you can convert it into a fraction. Let me show you some examples. So here are 5 statements that each have that word in them. And we're going to create fractions to represent that statement. So in the first one, this is a familiar one to you, hopefully. There are 24 hours per day. So I'm going to create a fraction, 24, let's use H for hours, for every 1 D for day. Or you can write out the word. Now the important thing to remember about these fractions is they can be written either way, because remember, they're just 1. 3 over 3 can mean the same thing if I flip it over. So it's going to be the same idea. So I could also write this fraction as 1 day, go ahead and write the word, for every 24 hours. It can be written either way. A few weeks ago you talked about fraction division. You learned this word, reciprocal. Right, so the numbers are reciprocals of each other, 24 over 1 or 1 over 24. Alright, you're going to write the fractions, remember 2 per each, for the rest of these statements. One about quarts and gallons and pounds per kilogram and gold at the bottom. Go ahead and write both sets of fractions for each of these as you pause the video. Ready, go. Alright, welcome back. For this one, we're going to have 4 cups per quart. Again, you can write the 1 if you want to. 1 quart for every 4 cups. You can write it either way. There are 16 cups for every 1 gallon. My line got a little out of the way there. Or you can write 1 gallon for every 16 cups. There are 2.2 pounds. Ooh, we can use the fancy abbreviation there, LBS for pounds, for 1 kilogram. That's what kg stands for. Or you can put the kilogram on the top and the pounds on the bottom. Gold weighs 10, let's use LB again, pounds for every 1 cup, or 1 cup for every 10 pounds. Right, either way. Hopefully you did well on those fractions because we're going to now use them to solve some unit conversions. First one says, how many hours in 3 days? So you want to think about, okay, what information do I have? I have days. Let's put that over 1 since it's a whole number. And I want, in my final answer, just hours. So I need the days to cross out. Right now they're in the numerator, so I need to put them in the denominator. And I know from my first fraction on the left here, there are 24 hours in 1 day, and the hours are in the numerator, which is how I want it. So I don't need to use the other reciprocal. The days will cross out, and I'm left with the numbers 3 times 24 and the hours unit. So 3 times 24. Of course, you can pause this and do that multiplication yourself, but your answer will be 72 on that one. Next problem, how many quarts are in 17 cups? So I have currently 17 cups. Let's go ahead and put that over 1 because it doesn't give me any other units. And I want it to be in quarts. So let's use my second fact over here on the left. There are 4 cups for every 1 quart. However, I know that I want the cups to cancel. So those are going to go in the denominator. 4 cups and 1 quart. Now my cups will cancel out. I'm left with 17 times 1, which is 17, and 1 times 4, which is 4. Of course, you can leave that as an improper fraction, 17/4 of a quart, or you can write it as a mixed number or a decimal. So as a mixed number, it'd be 4 1/4 of a quart, or 4 25/100 of a quart. Okay, the next one's kind of tricky because it has multiple conversions that you have to do. Let's look at it together. So how many kilograms per gallon of gold? Okay, our goal, I'm going to write my goal over here. It's always important to remember your goal. Kilograms on top and gallons on the bottom. Now let's look at the left. We got some information about gold and pounds and kilograms and gallons and cups. So let's use all the information that I have here. Let's start with the gold that we know, the fact we know about gold, which is that there are 10 pounds for every 1 cup. Okay. And we have something that compares pounds to, let's look here, pounds to kilograms. And so I can use that to get rid of pounds. They're going to need to be in the denominator, 2.2 pounds, and that's 1 kilogram. Okay, so I know that my pounds are going to cross out. Looking to the next fact that I know, there are 16 cups per gallon. So I'm going to be able to get rid of cups and have gallon in the denominator. So I need cups up here. That's going to be 16 cups, 1 gallon. So now cups are crossing out. And I'm left with kilograms on top and gallons in the bottom. For the math, we'll get 10 times 1, which is just 10, and then 10 times 16. So we have so far 160 in our numerator. In denominator we have 1 times 2.2 times 1, which is just 2.2. Again, you can do that division by hand, but the answer that you get should be 72.7. I just went ahead and rounded that. It does repeat 7272. We have 72.7 kilograms per gallon for that answer. Alright, I want you to try these two on your own. You might have to do multiple conversions on the last one, but go ahead and pause it and give it a try. Alright, welcome back. Our first one, the conversion is set up for us, so nice. And our answer is going to have the yards crossed out, and we're just going to have as our unit feet for every 1 mile or feet per mile. And we'll go ahead and multiply the numbers that are left. 3 times 1,760. We'll go ahead and do it on here so you can check your math as well. 0 times 3 is 0. 6 times 3 is 18. Let's bring that one up to regroup it. 7 times 3 is 21. Plus that one more is 22. Bring the 2 up. 1 times 3 is 3. Plus 2 is 5. So our answer is 5,280 feet in 1 mile. Feet per mile. Alright, this next one's similar to the gold. We're going to have multiple things that we're going to use, multiple conversion factors. My sprinkler sends out 5 gallons per minute. There's our first fraction. 5 gallons, 1 minute. And we might need to use reciprocal instead. I'm just writing our fraction as is for now. And water costs, there's another fraction, 65 cents for every 1,000 gallons. How much does watering my lawn cost? So my final goal, remember, is going to be cost. Per means divide, excuse me, hour. So I want dollars on top and hours on the bottom. So let's look at what we have so far. If I were to multiply these two, the thing that's crossing out is gallons, which is good because I don't have any gallons in what I want for my answer. Excuse me. So I'm going to have dollars on top. That's what we want. And now I just need to get rid of minutes. And luckily we know there are 60 minutes for every 1 hour. Okay, I want you to go ahead and try the math and see how it goes. Okay, welcome back. This is how I've got so far. I've got 0.65 times 5, and then times 60, so I'm at 195. Whoops. My money, and remember minutes crossed out as well as gallons, and then in the denominator I have 1,000. So we do 195 divided by 1,000. That would just be 195 thousandths. So as a decimal, it would be 0.195. So about 19.5 cents per hour. Of course, if we want to do dollars and cents, we're going to round to the nearest hundreds place. So that would be about 20 cents per hour to mow the lawn. Now, it's not saying we're going to water it all day or anything like that. We're just saying how much does it cost for 1 hour? About 20 cents for that situation. And that is unit conversions. Remember, conversion means to change. So we're just changing the units of measurement for each of these, and that's helping us to solve problems. Go ahead and try some of the exercises in your book and see how it goes. Good luck!